So the question here, that is number 2 in exercise 3. It says, find the point of inflation, if any, on the graph of the function y is equals to 3x to the power 5 minus 5x to the power 4 plus x plus 4. Alright, so it's very easy. Let's go straight to the point. How do you find point of inflation? Step 1, differentiate the function 2 times. So we have the function solution. We have the function y equals to 3x raised to the power of 5 minus 5x raised to the power of 4 plus x plus 4. dy over dx is equals to, now you know how to differentiate, so 5 times 3, 15, x raised to the power 5 minus 1, 4, minus 4 times 5 is 20, x raised to the power 4 minus 1, 3, plus the derivative of x is 1. And the derivative of a constant is 0. So plus 0, no need. All right. We're done with differentiating the first derivative. Now, second derivative is the square y over the x square, which is equals to 20 times 15, 60, x raised to the power of 3, minus 3 times 20, 60, x raised to the power 3 minus 1, 2. The derivative of a constant is 0, so we are done differentiating. Next, you equate the second derivative, which is 60x cubed minus 60x squared, to 0. So that means 60x cubed minus 60x squared is equals to 0. So this is a cubic equation. That's equation of power 3. At this point, what do we do? First of all, you factorize this equation. Factorize the expression at the left hand side. So I have 60, I have 60, I bring out 60. That is factor out 60. I have x squared. Inside x cubed, there is x squared. So x squared is common, x squared is common. I factor out x squared. What am I left with here? Remember, I have factored out x squared. So 1x is left. Look at it. Minus nothing left here because 20x squared is out. Look at it, 20x squared. So that means what is there is 1. Equals to 0. From the study of quadratic, we said that when the product of two terms is equals to 0, it means it's either the first is equals to 0 or the second, x minus 1, is equals to 0. So from here, we can find the value of x. So that means x squared is equals to 0 divided by what? 60. Which means that x squared is equals to 0 divided by 60 is 0. So x is equals to, when this square crosses equality sign, it becomes square root. Square root of what? 0. Meaning that x is equals to 0. Okay. Or x minus 1 equals to 0. Or x minus 1 equals to 0. Meaning that x is equals to minus 1 will cross and become plus 1. So therefore, x is equals to 0 or 1. So these are the two values of x after solving this quadratic. Now, the point of inflation will actually occur at the point where x is 0 or where x is 1. How do you know the point of inflation will occur? You will carry out an analysis or a test. And what do we do? First of all, we pick the first value of x, which is 0. So at the point x being equals to 0, at the neighborhood, the region between this number 0, we have numbers at the left of 0, and we also have numbers at the right of 0. Of course, if you have something like, say, this is 0, the left number at the left and number at the right. Number at the left of 0 is minus 1, and the number at the right of 0 is plus 1. So we are going to check. That means as the curve moves from minus 1 to 1, what happens? Is there a change in the curve? Let's find out. So what do? Pick this point here, that is at the left of 0, minus 1, and put it into the first derivative. And what was the first derivative? dy dx equals to 15x raised to the power of 4 minus 20x cubed plus 1. So at x is equals to minus 1, this is the point now we are substituting. We now say that dy dx is equals to 15 into minus 1 raised to the power of 4 minus 20 into, put minus 1 there, raised to the power of 3 plus 1. So minus 1 raised to the power of 4 is positive 1. 1 times 15 is 15. So we have it that dy dx is equals to 15. Okay. Then minus 1 raised to the power of 3 is minus 1. Minus 1 times minus 20 is plus 20. Then plus 1. Plus 1. So that means that dy dx is equals to 15 plus 20 is 35 plus 1, 36. What type of value? Is it positive or negative? Of course, it is positive 36. Now let's check for the right of 0, which is what? 1. So put 1 in the first derivative. Okay, so dy dx will be at x equals to 1 minus, okay, sorry, 1. We've put minus 1 now, let's put 1. So we have that dy dx will be equals to 15 into 1 raised to the power of 4 minus 20 into 1 raised to the power of 3 plus 1. So this is equals to 1 raised to the power of 4 is 1. 1 times 15 is 15. 1 raised to the power of 3 is 1. 1 times minus 20 is minus 20 plus 1. So it means that dy dx is 15 minus 20 is minus 5. Minus 5 plus 4. Sorry, minus 5 plus 1 is minus 4. So automatically, the first value was plus 36. The second one is minus 4. So automatically, the point of inflation does not occur at the point where x is equals to 0. Why? Because there is a change in sign from positive to negative. So it doesn't occur at the point where x is 0. That means that you have to test for the second point, which was what? 1. The number 1, at the left of 1, you have 0, and at the right of 1, you have 2. This is 1. At the left of 1, you have 0, at the right of 1, you have 2. So you are going to check for these 2 points, 0 and 2, and see whether a change will occur or not. Let's go. Okay. All right. So at x equals to 1, okay, what is the region? It is 0 and 2. So let's find dy dx. That's the first derivative at the point 0. The first derivative is dy dx is equals to 15x raised to the power of 4 minus 20x raised to the power of 3 plus 1. So let's put it there. That means that this will be 15 into, what is x? 0 raised to the power of 4 minus 20 into x is 0 raised to the power of 3 plus 1. So this is 0 raised to the power 4 is 0. 0 times 15 is 0. 0 raised to the power 3 is 0. 0 times minus 20 is 0 plus 1. So you have plus 1 as the answer, which is positive. So that can be positive 1. So dy dx at the point where you have 2 will be equals to, let's put 2 in this function. Now that will be 15 into 2 raised to the power of 4 minus 20 into 2 raised to the power of 3 plus 1. 2 raised to the power of 4 is 16. 16 times 15, that will give us 240. Okay. 2 raised to the power 3 is 8. 8 times 20. Please note there's minus there. 8 times minus 20. So that will be minus 160 plus 1. Okay. 240 minus 160, that will give us 80. 80 plus 1 is 81. So this is equals to 81. So, and 81 is positive. So we can see at the 0 point, we have plus 1, and at 2, we have plus 81. So as it moves from 0 to 2 on the curve, there is no change. Positive 1 and positive 81. So since there is no change in the movement from 0 to 2, it means that the point of inflation occurs at the point where x is equals to 1. It's either you call it point of inflation or you call it the saddle point. The saddle point. Okay, so that's where the saddle point occurs. Then finally, you pick that point, which is 1, and put it into the original function y equals to this. You put it here. So put 1 in this. You have 3 into 1 raised to the power of 5 minus 5 into 1 raised to the power of 4 plus 1 plus 4. So this is equals to 1 raised to the power of 5 is 1. 1 times 3 is 3. 1 raised to the power of 4 is 1. 1 times minus 5 is minus 5. 1 plus 4 is 5. So 3 minus 5 is minus 2. Minus 2 plus 5 is 3. It means that the points are at x equals to 1, then the function y is equals to 3. So these are the points where the critical point occurs on the curve of the function y equals to 3x raised to the power 5 minus 5x raised to the power of 4 plus x plus 4. So that's how to find point of inflation on a curve.